All right, here we go. Question number 12 from our Precalculus homework number 12 in MyLab Math. They want us to solve the following system of equations, again using matrices with row operations. If the system has no solution, say that it is inconsistent. And so, just like we did in the last example, the first thing we need to do is copy and paste our equations into the Scratch work and get started. And maybe you can see this time I was super lazy and didn't want to write those, so I just really copy and pasted them here into my Scratch work. And we're going to have to convert into matrix form. So notice that my X's, my Y's, and my Z's, those are all lined up like they should be, equals the constants. It is important to check and make sure that your equations are in the right format before you start writing your augmented matrix. All right, so here we go. First row, we're going to have negative 1, 1, 1, negative 1, and the vertical bar represents the equal signs. That makes it an augmented matrix. Next row, we're going to have negative 1, positive 4, minus 14, minus 16. Last row, 5, negative 4, negative 10, and 0. And once we have our augmented matrix, then we need to take an inventory to see where we're at on the journey to row echelon form. So looking at our major diagonal, those all need to be 1s. The other 3 numbers below that diagonal need to be 0s. And the first element that we need to convert is the upper left-hand corner. That has got to be positive 1. Now the way we're going to achieve that objective is through a row multiplication. So what we're going to do is we're simply going to multiply row 1 through by negative 1 to produce a new row 1, which indicates rows 2 and 3 are not going to change this time. So the first thing I want to do is copy and paste the stuff that doesn't change. And then once we have rows 2 and 3 copy and pasted down here in our new matrix, we need to execute the row operation. Multiplying row 1 through by negative 1, all that's going to do is it's just going to change the signs. So that'll be 1, negative 1, negative 1, positive 1. And now we can see that our first objective is achieved. The next 2 objectives are to make the negative 1 and the 5 become 0. Now the way we're going to achieve those objectives is through row multiplication with addition. So actually technically if you look at what's going to happen here for the first element, for the negative 1, if I simply add row 1 to row 2, 1 plus negative 1, that'll make a 0. So our first row operation is going to be simply to add row 1 to row 2, and that'll produce a new row 2. Now I am going to do 2 row operations at one time to save time and space. We also need to convert 5 to 0. The way we can achieve that is by multiplying row 1 by negative 5, adding to row 3 to produce a new row 3. Okay, so if you look what's going to happen, we're going to have 1 times negative 5, which is negative 5, and then adding to the corresponding element in row 3 will produce a 0. So now we need to execute the row operations. Notice that rows 2 and 3 are going to change. So the first thing I want to do is copy and paste row 1. And since I have covered this previously, I'm going to go a little bit faster using my row operations. The first row operation, we're simply adding row 1 and row 2. Notice I did copy and paste row 1, so that part is done. Adding rows 1 and 2, 1 minus 1 is 0. Negative 1 plus 4 is 3. Negative 1, negative 14, that's negative 15. And negative 16 plus 1 is a negative 15. Next row operation, we need to multiply row 1 by negative 5 adding to the corresponding element in row 3. Negative 5 times 1 is negative 5, plus 5 is 0. Next, negative 5 times negative 1 is 5. 5 minus 4 is 1. Next, negative 5 times negative 1 is 5. 5 minus 10 is minus 5. And one more time, 1 times negative 5 is negative 5. Negative 5 plus 0, negative 5. And we're done with those two row operations. Notice what that achieves is the first column is the way it should be on our journey to row echelon form. And then the next element we need to get correct is the 3. Now notice below him is a 1. If I simply do a row swap, that'll get me a 1 in the middle row where I need it. So the next row operation we're going to do is a simple row swap. All right, so here's what we're going to do. Next, we're going to swap rows 2 and 3, which means that row 1 is not going to change. Notice I've already copy and pasted him down here. And then row 3 is going to become row 2. So just copy and paste him. And row 2 is going to become row 3. And now that row operation is done. Now if we look at where we're at on our journey to row echelon form, the next element we need to convert is 3. 3 needs to become a 0. And remember I said once your first column is the way it should be, you don't use row 1 anymore. Now we're going to switch to using row 2. Think about this. What would I multiply 1 by that when I add it to 3 would give me a 0? Well, the answer to that is negative 3. So next we're going to take negative 3 times row 2 and add it to row 3 to produce a new row 3, and that should achieve this objective. Okay, so if you can tell what's happened, I have written my new matrix. Remember, only row 3 is going to change. So I've already copy and pasted rows 1 and 2. And now we need to execute this row operation. Multiplying everybody in row 2 by negative 3. 0 times anything is 0. Adding to the corresponding element in row 3 will retain the 0, which is important. Next, negative 3 times 1 is negative 3. Negative 3 plus 3 is 0. Remember, I designed it that way, so I should get a 0. Next, negative 5 times negative 3 is 15. 15 minus 15 is 0. And then one more time, negative 5 times negative 3 is 15. 15 minus 15 is 0. And now, I've got a bad feeling about this, actually. If we look at where we're at, notice that this element here, not only did we get this to be a 0, but this element here is now also 0, and there's no way to get that 0 to become a 1. So this is a special case that you need to be aware of. When your last row turns out to be all zeros, if I convert that back into an equation, that would say 0 equal to 0, which is a true statement. And that means that there are infinitely many solutions here. This indicates that the equations are dependent, meaning there's going to be an infinite number of solutions, and we need to know how to write that solution. So what you do in this case to represent the solution of a dependent system is you start with your last row, which is where we would normally get z, and we say that we can let z be any real number. Okay, z is any real number. In other words, you can pick whatever you want for z, but once you've chosen a number for z, x and y are going to depend on that. So that's where we're going to take our second row and convert it back into an equation and figure out what y is based on z. So that will give us, well, no x, 1y, minus 5z, and this time remember z is basically a variable that can be anything you want it to be, so it's going to stay z equals negative 5, and then I'm going to solve for y. Moving the negative 5z over is going to tell us that y must be 5z minus 5. And so do you see that if I can pick any number I want for z, then I can plug that in and determine the value of y. And then the next step is to figure out what x is. And that means going all the way back to the original equation. Here at the top, we're going to convert this first row back into an equation and solve for x. So that's going to give us x minus 1 times y. But remember, y is 5z minus 5, so I'm going to substitute for y what it's equal to, and then minus z, do you see that's from here, minus 1z equals 1, and now I've got everything in terms of x and z. I can solve for x. So distribute the negative 1, that's going to give us x minus 5z plus 5 minus z equals 1, and then combine like terms. Negative 5z minus z, that's going to give us negative 6z, and so if I scroll up just a bit, we're going to have x minus 6z plus 5 equals 1. Moving the minus 6z and the plus 5 over to isolate x. That's going to give us positive 6z. The plus 5 becomes minus 5. 1 minus 5 is minus 4. And now we can see what x is in terms of z. So if you're following along here, now we know x in terms of z. We know y in terms of z, and z, we get to pick whatever we want. And so now we need to go back to the MyLab math and see if we're right. So back here in our MyLab math window, there are two choices for infinitely many solutions. And so if you focus at answer choice C, it says the solution can be written as, well, an ordered triple. Y is any real number and z is any real number. That is not correct, because remember, y in this case is based on what z is. So we can't just pick anything we want for y. We're going to have to calculate y based on what z is. And so that's going to mean that our answer choice that we want to select is B. And then we're going to input our equations in terms of z that we got for x and y. So x was 6z minus 4, and y was 5z minus 5. And checking to see if we're right, and we are. And that's going to do it for that problem. So if you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.